Great. So heavens-above.com, one of the things that you can see are comets. What's up? So what are the two places comets are? So where are the comets? Oh, the sun's in the way of the cards. Wow. Okay, what's this thing called? It starts with a K. Kuiper belt, very good. And then what's this thing called? Just let it go. Oort cloud, yep. Very good. Those two places. So usually those icy, rocky objects are out here minding their own business. I know it sounds kind of strange, kind of bizarre, but actually they can get pushed from another star, okay, to give them kind of a trajectory that will bring them in towards the sun. So as they come to the sun, at some point, they're going to start gassing. Okay, so basically they're going to start fizzing. They'll create these tails. Now, one of the cool things about tails, and I'll try to convince you of this, is it's not like a kite tail where you're like, oh, the kite tail always goes in. No, the tail will always go away from the sun. So here in a minute, as I go, so what do you think? As it comes closer to the sun, will it go faster or slower? Faster, exactly. It will go faster and faster. It'll go meow, and then it'll go back out like this. It'll slow down. And the cool thing is as it leaves, actually its tail will go in front of it. It's because the solar wind is blowing the tail. So its tail goes in front of it. Isn't that neat? Yep.
How far does it go out before it changes the tail?
Well, the tail will always blow away from the sun. So if you find the sun, you know the direction of the tail. And there's actually two tails. It's kind of subtle. I'll show you that. But that's why it glows. Sun grazers, sometimes you'll hear astronomy people talking about kamikaze comets. So what does that mean? They don't make a circle, okay? They basically get too close to the sun and they go into the sun. And there are all sorts of spacecrafts watching the sun. So that's kind of in a weird sort of way, kind of a fun thing to watch. Actually, there are videos out there watching a comet going to the sun, plunge into the sun. Comets are named after the person who finds them, but in the old times before computers, that was really exciting. These days, it's kind of, my astronomy friends kind of keep me clued in how this works. A lot of times, it's just a computer program out there watching the skies, and that computer program's name will be associated with a comet. You know what I mean? Yeah. Messier, remember, was looking for comets. So it can do this about 100 times. Usually, depends on how big the nugget is, right? Because you figure it's losing its material as it's gassing. It orbits the sun, goes back out, and then it stops gassing. It can do that about 100 passes. So Comet Halley is kind of relatively short. Took 76 years to do that one. So comets, they have an identity all of themselves. This is Comet Halley. Let's just see some other pictures. And you can kind of see, and I'll just kind of give you a heads up. Of course, we call this the tail. Okay, this glowing area actually is called the coma. And in a minute, we're going to be able to kind of see the rocky part in there, and that's going to be the nucleus.
Is the light that it produces relevant to the materials?
Yes, I would say so, yeah. The color of the light that it produces is an indication of the materials that are fizzing, yes. Yep. These actually, I'll dim the lights. I took a picture of, it says last fall, it's been a few years ago. But this is Comet Lovejoy, so it was found by Mr. Lovejoy. And so I photographed this one. And you mentioned color, this one's just green, a lot of green comets out there. And it has a lot of coma, not much tail. So here's my official slide on the anatomy of a comet. And actually this is one of the terms that's fresh in my mind. Your test is fresh in my mind. This is one of the terms that is on your test. So the the anatomy of a comet, you know what I mean. So the nucleus is kind of hiding in there. That's the nugget thing. That's as it was before it started fizzing. The coma is kind of the swelly region around the nucleus. And it's got two tails. It's got a plasma tail, and if I was, I'd probably write these on my note card because I get them mixed up. Plasma tail is straight, and the dust tail is arched. To me, that kind of, and you won't always see the plasma tail and dust tail from a comet. Sometimes you'll just see tail. Sometimes you won't see a tail at all. Like on the one I showed you that I photographed, Comet Lovejoy, I only saw a coma. But those are kind of what you see. And I like this figure down here. This figure is showing you, of course, here's the, this Earth's orbit, yeah. Okay, so here's the sun here. And can you see, we talked about the comet tail. Now, the way this is showing you, I see an arrow here that's showing us the comet is going like this. Okay, and so as it gets closer, it begins to fizz. Okay, here we have a tail, but notice that even though it's going this direction, the tail goes out away from the sun, always away from the sun. Always away from the sun, sun, sun. And so as it's leaving here, even though it's going this direction, the tail is like this. That's kind of how that works. Haley again, pretty cool. I'm going to show you some pictures here of actually, maybe you know that I think the spacecraft called Rosetta landed on a comet. No, it didn't land on a comet. It sent a lander down called Philae down to the comet. So that's pretty cool. Another comet. This particular mission was to take a comet and pick on it. So what they did, and honestly, one of the things we're going to talk about is this idea of protecting the Earth from comet impacts, from asteroid impacts. So we play with comets out there. So Deep Impact actually struck the comet, and I've seen a video like this. I don't have the video. Maybe I'll go ahead and try to put it up on Canvas. But if you watch the video, it's like stuff kind of flies out and then it kind of sucks back. It's kind of creepy. But anyway, so it struck the comet. Another comet. This one right here, this is the close-up of a comet called, it's German, okay? This one right over here. And if you look real closely, I talked about that we have landed on a comet. So there is the lander right there that came from Rosetta. And if I'm thinking of it right, I think that this particular comet is on its way out. They picked a comet that wasn't fizzing, basically, because it was nice and tame and quiet, right? And there was definitely some surprises. I just think that is so cool.
I think that there would be more round.
Yes, you would think it'd be kind of more round. It looks really chunky. And things only become round if they have enough mass, yeah, to kind of round their edges. So this is still that same comet that Rosetta orbited, set the lander on. And I mentioned it had some surprises, okay? If you watch the science fiction movies, one of the things they might talk about is kind of some random activity. A little jet here is kind of, and according to Newton's third law, if you get a jet here, you're going to get some sort of motion with the comet. So it's the action-reaction sort of thing. So, very cool. Now, we talked about meteoroids, meteors, and meteorites the other day. And I kind of say them in that order for purpose, because meteoroids is space, meteor streak, meteorite, you pick it up. Okay. So I saved meteor showers, though, for now, because we will need to talk about comets before we talk about meteor showers. And that's because that in a meteor shower, okay, let's see how do I do this. That's the sun. Okay, there's the sun, then I'll be the Earth, yeah, and I'm gonna orbit the sun counterclockwise. Okay. So we talked about comets. You know, they come in, they kind of disintegrate, then they come back out, right? Well, as they disintegrate, they leave little crumblies in their path where they were. Just so happens, in some cases, there are little crumblies left by a comet in Earth's orbital path. So then what happens is the comet's not there, but the Earth is pushing through debris left by a comet. And that's when we have our meteor showers. So the other thing is where the Earth is at in its orbit is kind of tells us what stars we see, right? Where it's at. So because we see different stars over here, we see different stars over here, right? So kind of along that line, when we are pushing through, when the Earth's pushing through comet debris, the kind of, we call it the radiant, where it's coming from is going to come from a specific constellation, a specific set of stars. I kind of went like this, but actually it's kind of like this. We see them kind of radiate out. So it's kind of cool. So the list looks like this of the major meteor showers. You might recognize, we saw Lyra the other night. Lyra is like the harp. Okay, so the Lyrids would look like they come from Lyra. So what the Lyrids is a meteor shower. They peak about April 22nd, and this last comet, or last column, says what comet left that debris. See how that works. Very cool. So what constellation does the Orionids look like it comes from? Constellation Orion, yep. Taurids. Taurids, yeah. I wish there was one more column, I don't think there is. Wish there was one more column over here that said, I think it's called the ZHR. One more column that says the 0 hourly rate. Because this tells you how hardly you want to do to try to watch that meteor shower. The ones I picked out for like next month about I didn't pick it out, it just so happened, about a new moon, that particular meteor shower has a pretty high 0 hourly rate, which means that hopefully we'll see all sorts of kind of meteors flying off.
Was that the Leonids?
Is it the Leonids? That sounds right.
November 17th, I guess. Is that?
Yeah, but so, no, this would be the Orionids, I think.
Oh. Isn't the Leonids the big one though, that usually?
The big ones to me, if you look at the hourly rate, oh my gosh, and I know it's cold, people, but hello, the constellation Gemini in December, wow, I think it's like 80 or something, 80 per hour. So do the math, 80 per hour. So more than every minute you should see a streak. Now the darker the skies, the better. So that's cool. The other big one is the Perseids in August. It's a really good meteor shower. Maybe it's because it's August, it's nice to get out, but it's also, I can't remember what that 0 hourly rate was. But if you read up on, I tell students or anybody, if you want to do a meteor shower, get online and kind of get the details. Now, they will tell you, for instance, if just because they know where the crumblies are, they have a sense of where the debris is that the Earth is going to push through. And sometimes they're like, dude, this is going to be a great meteor shower, okay? Just because they're kind of aware of some of the other dynamics of it. Or not a very good meteor shower. Full moon, no meteor shower, okay? But this sort of idea is kind of, you're driving a car, but that kind of reminds me of driving a car in snow. Haven't you ever been mesmerized by the snow that you're, yeah. So I mentioned kind of the radiant. It kind of looks like it comes from one central location. All right. I have several slides, and it didn't make it to your test this semester. It was on your previous review sheet, but not on this review sheet, so it won't be on your exam. But this idea of the planet Jupiter and its close call. So this is Jupiter. We'll talk more about Jupiter. Jupiter has some spots. They're large. The spots are like hurricanes when we talk about hurricanes. So this is a white spot. There's a great red spot. This is Jupiter up here. Okay. And back in 1994, a comet, now I have to switch from the Earth to Jupiter, but I guess I can do that. Okay, so now I'm Jupiter out here, okay, and I'm minding my own business. The cool thing about the 1994 event was they knew that they knew it was coming. Was it 4 years? I'm not sure, but they had advance notice. It's basically this comet that came from out there, it had broken up into pieces and Jupiter was going to plow into it. So all eyes were on Jupiter, so we got some great shots of this. You're going to see them here in a minute.
So did it dissolve or?
Yeah. The comet fragments were, well, I don't know what we call that. That's actually kind of showing an impact of the comet fragment into Jupiter. Jupiter, what do you think, size-wise? Jupiter, pretty big?
So you put all the other planets in it.
Yes, you could put all the other planets in it. And so you can kind of get a sense for size for that impactor. So this is again, and again, the comets are named after who finds them. So 2 people found this, Shoemaker and Levy. So it's called Shoemaker, Levy, and this might have been their 9th comet that they found. So this is the fragments right here. This right here, this is so cool. So some of you who went to the first lab, did you see Jupiter? Yeah. And there are 4 moons that are really bright. And this actually, can you see this little silhouette? It's adorable. That, I think the caption says, is Io. And that is one of the Galilean moons that orbit Jupiter. And so what you're seeing, kind of hurts my brain a little bit, but what you're seeing is basically a shadow. You know, the sun is, how do I say, Io is blocking out some of the sunlight to hit Jupiter, so it's a shadow actually. Kind of neat. But anyway, yeah, these are the impacts. More. Now down here, this actually is the same comet event. If you look here, this is unusual. This is an unusual feature of Jupiter. Jupiter usually has these what we call bands, called belts and zones. They have little circles that are called storms, but this actually is from the comet impacting it. So, as I understand it, a lot of great science came from observing the impact. Okay, speaking of impacts, switching from Jupiter to the Earth, in general, well, first off, if I was going to ask you maybe to describe the moon, you hopefully would say it looks pretty cratered. There's a lot of craters on the moon. But the Earth has been hit just as much as the moon. The difference is that the Earth has these plate tectonics that has kind of smoothed it over. The other thing about the Earth is it has wind. This erosion has kind of smoothed it over. Water has kind of smoothed a lot of the impact craters over time that the Earth has experienced. But a few impacts I want to talk about with regard to the Earth. Probably the biggest one was the one kind of being described here. It occurred 65 million years ago. Now you'd be like, well, how do we know the timing? And one reason we know the timing is by looking at these rock layers. The way a lot of rocks work, sedimentary rocks work, is the lower the rock layer, the older it is. Okay, so you could kind of go back in time as you're going down in the layers of rock. So one of the layers of rock actually, if I put IR, I think it's probably on this slide, that's the element iridium. Okay, we don't have a periodic table in here. But iridium is not very common on Earth's surface. Okay, iridium is a relatively heavy metal. Iridium you'd think might be at the Earth's core. Okay. But here, about 65 million years ago, there's a layer that covers the Earth of iridium. And the deal with iridium is that although it's unique to Earth's crust, it is abundant in some asteroids. Okay, so space rocks, asteroids, and comets have iridium. So the thought is actually that's one thing that supports this idea that material from a comet or an asteroid actually spread throughout the world, global dust, about 65 million years ago. And that coincides with the beginning of the demise of the giant dinosaurs. So the way this works is this impact would stir up dust, block sunlight, no plants. No plants, you know, if you're a dinosaur that eats plants, there goes your food source. If you're a dinosaur that eats other dinosaurs, well, your food source just died because of the plants dying. So that's kind of
a documentary about that said that it's possible that it landed in like the Pacific Ocean, that's the deepest ocean, and then that's why it's so deep, is because of the
Interesting. So that's that impact. Here's another impact. This is in Russia, and this is actually taken 21 years after the event. It's called the Tunguska event, and it happened in the vicinity before World War I, and that actually politics made a play in, was a part of why scientists weren't able to kind of rush over to it. But not very populated, and there's no smoking gun. There's no like really humongous impact crater, but there is just a devastation. Like you see these trees being knocked down like toothpicks. And so I've heard different things. If you Google Tunguska event, and I think what I'm most likely to believe is that it was an impactor, probably a comet, that as it came into Earth's atmosphere, it blew up, probably before it really impacted the Earth. That's the Tunguska event. This is here in the United States. Okay, so this is in Arizona, Winslow, Arizona. And there would be, I'm pretty sure there's a central peak in there, I think. It kind of reminds you maybe of a crater you might see on the moon. But the reason that it's not resurfaced due to wind erosion and or plate tectonics is it's relatively new, 50,000 years. And this was a thought where the impactor for the dinosaurs may have been. Can you guys see this? It's like a cloud moving across the PowerPoint slides. It's just mine. Okay. This is the Tunguska event again. This one right here, do you guys remember? It was like on Valentine's Day. I know that. And I don't remember what year, but there was a big hairy deal in Soviet Union. And one of the things that we kind of joke about is it was caught on camera, in part because in the Soviet Union, you need cameras to protect yourself if you're driving a vehicle because of litigation, people saying that you did something that you didn't do. So we have all these dash cameras, on their cars. So anyway, yeah, this was a big hairy deal, and I think they recovered the meteorite, I think. It wasn't a humongous meteoroid that fell through the earth, creating the street we call meteor, pick up a meteorite. But it played havoc with sonic boom in nearby towns. They had their glasses broken out and everything. So anyway, so that kind of leads us to this idea of protecting ourselves. So what are we doing to protect ourselves? This graph is showing you the discovered, one way to call these objects are just near-Earth asteroids. More generally, you're going to see on the next slide, instead of NEAs, near-Earth asteroids, excuse me, they're called near-Earth objects. Same idea, objects just being more general. These could be asteroids, meteoroids, comets. And you can kind of see the amount we've discovered. Why do you think there's so many more here than there was back in 1980? What?
Is technology advanced?
Yes. Yeah, technology's become more advanced and we just know they're out there. So, will we be struck again? And I know that with the Valentine's Day meteor that happened in Russia, that there was a lot of discussion about that. And I can remember Neil deGrasse Tyson said, the thing is, if you take the Earth, a lot of the Earth is uninhabited, like the oceans, that sort of thing. And so actually we might have more of these large impacts than you actually know or think about. But so it probably will be hit again. Now, I don't know if you guys can read this, But down here we have atmospheric explosion or small crater, okay? And then here along the y-axis, we have how long it will take to have that event. So every 1 million years, you expect something kind of like that. Okay, maybe like the Soviet Union, sort of Valentine's Day thing. This says widespread devastation. This is every 1,000 years to 100 million years. And this down here says mass extinction. You're talking every 100 million years to once in Earth's history. So it's kind of like that. This right here is showing you again the Valentine's Day event. Looks like it was in 2011. Wait, no. Yeah. 2013. Recent impact. It wasn't Valentine's Day. It's the day before Valentine's Day. It's close. Before I go on, I do want to take you to this website, and so let's see. It's kept up to date, pretty good. NASA has some great websites out there. This is one of the many. So this talks about a close approach. Let's see. There's a cool table. Let's see if we can find it. I'll go under close approaches. NEO stands for near Earth objects. So here's that cool table I was showing you about. So the object's name, when it's going to approach. Let's see. These are, yeah, these must be upcoming. So LD stands for lunar distance. To AU stands for distance, average distance between the Earth and the Sun. Estimated diameter. So there you go. All right. So here's a little plug for our friend Jupiter. Our friend Jupiter out here, you told me, is very large, very massive, and actually over the history of our solar system has done a lot to kind of be a linebacker and block a lot of otherwise incoming things to the Earth. So this one, I think there's, so these will be due on, Wednesday? No, Monday. You can take your test. These will be due on Monday when you come take your test. Remember, you can do them by the end of the day, so if you're up late studying for your test, know that you can still turn them in by 3 p.m. It's fine, or turn them in electronically. And these say, is this the one I was going to say? Yeah, what did I say? How many do these? 3. Yeah, do 3 of these. All right, let's take a quick look at Pluto.
So do we do all of 1.8 A, B, and C? Is that what?
So all of 1.8A, and for B, it's only 3, and for C, there's only 1 question. So the longer there's a distance between having only 8 planets in our solar system, versus, I'm talking about the demotion of Pluto. My point is, kids are going to be growing up and they're like, oh, of course Pluto's not a planet. Whereas us, we're kind of like, I have a t-shirt that says, bring back Pluto. So it's just kind of funny. But Pluto is a dwarf planet. So kind of putting things in scale here, I think I already showed you this slide before, but this is the Earth, and Sirius and Vesta, what are they? Do you remember?
Dwarf planet.
They're dwarf planets, and where are they located?
Asteroid belt.
They're in the asteroid belt. Yep, they're asteroids, dwarf planets in the asteroid belt. Yep. Let's see, anyway, Pluto. Pluto has 5 moons that I know of, and the largest moon is called Charon. You can kind of see it here. That's how you spell Charon. This is hard to make out, but this is kind of, again, showing you different objects in the solar system, not necessarily to scale. So this is young Clyde Tombaugh, And what? Let's see, is he from Illinois? Okay, I think he might be. But anyway, he was the person who originally found Pluto. He found Pluto kind of like we find asteroids, which is, it was a little dot of light that moved against the background stars. So, good for him, Pluto. This is showing you Earth, Pluto, and its biggest moon, Charon, kind of to scale compared to the Earth. So now I've got some pictures of Pluto. This is a picture of Pluto, and you can kind of make out, does it look like it has an atmosphere? Pluto does have an atmosphere. This was taken by the spacecraft New Horizons. Now, spacecraft do different things. Spacecraft are inserted into orbit. Spacecraft land, okay? Spacecraft, in this case, was a flyby. So, New Horizons is on its way out to the Kuiper Belt for exploration. And this is one of my favorite pictures, yes. This is the one where you can see Pluto has a heart. I know, you're right, really. When New Horizons sent back this photo, it was like people were saying, well, now that we see it has a heart, can it be a planet again? No. So, this talks about a variety of terrain on Pluto. This is kind of a close-up of this would be the heart over here, okay, and kind of the other part. It's just amazing to get those close-up pictures.
Why would they make it a planet back in the day and then decide?
Well, Clyde Tombaugh, to his credit, could see that it was orbiting the sun.
Right.
So why, wouldn't it be a planet? I don't know. But, I don't know.
I just can't get it out of my mind. I mean, I grew up with 9,
But you said, why did they make it a planet in the first place?
Yeah, right?
Right.
So, I mean, if you're going to demote it.
Yeah. Now, what is a comet made of? It's made up of two things, kind of. Rocks and ice, yeah. And that's kind of what Pluto is made up of. So Pluto's kind of like a comet. Like a round comet. More pictures of Pluto. Just so cool. What's that? Okay, so then that's the only question you need to answer for this part. Are there any questions about? Okay, well, good job. Unit 1 down. Unit 1 test to come, and then on with Unit 2 on Wednesday. Let me know if you have any questions on that video out there.
So our,
That's what I'm on video, I'm gonna be like that.
I keep thinking you're going to say something. No, you're just moving.
I'm gonna be suffering.